Hello, how's it going? Algebra 2, what's good? It's Mr. Skis. Welcome, welcome. We are just coming off our Unit 6 test. I'm not there today, as you can see, but I just wanted to let you know that yes, we'll do retakes. Yes, they'll be this week. What I'd like you to do is just come in Wednesday or Thursday after school for retakes, okay? So that gives you today, tomorrow, potentially Wednesday to study, look back at some things, and then I could retake on Wednesday or Thursday. Okay. So just clearing that up. And we are starting Unit 7. We just concluded Unit 6, of course. We're starting Unit 7. And spoiler alert, we're skipping 7.1 of the student journal. So I'm going to go ahead and switch to over here. And we're looking at 7.2 of the student journal. So whoever's covering my class, if you need to pause it real quick while everyone pulls that, now's a great time for that. So I'm assuming we all got it pulled out now. 7.2, the student journal. So we're looking at rational functions. So let's just take a look at, I'm going to jump straight into the exploration as we usually do. Work with a partner. Each function is a transformation of the graph 1 over x. Match the function with its graph, explain your reasoning, then describe the transformation. Okay? So when it comes to 1 over x, this is the parent function, okay? This is the parent function, meaning every function is going to resemble this, okay? And spoiler alert, this is called a hyperbola, okay? So we've had parabolas, we've had logarithms, we've had roots, we have a hyperbola, okay? And you can see here that where hopefully you can kind of see that there is an asymptote vertically and an asymptote horizontally. Okay. So the horizontal asymptote and the vertical asymptote. And what's causing these asymptotes? Well, if I could hear your voices, this is the question I'd ask you, and I'd wait for someone to answer it for me. Is okay, look, these all have a denominator, right? We have these fractions now. What's something that you can't divide by? What number can you not divide by? And I would wait for a hand, and I would hope for the answer 0. You cannot divide by the number 0, okay? So, a little star here, you can't divide by 0. So, when you look at these functions, what number would cause your denominator to be 0? X cannot equal 1 because 1 minus 1 equals 0. You can't divide by 0. So what does that mean if you can't have x equal to 1? Well, if there's a restriction, if there's a value being excluded, it forces a restriction. And what's the best way to represent a restriction? That is with an asymptote. Okay, so because x can't equal 1, we know there's going to be an asymptote. This means x equals 1 is an asymptote. Okay? That's what that means. So when looking at these functions, when looking at these graphs, I should say, this is a plausible option, x equals 1. Where's another x equals 1? Right here, x equals 1. That's a vertical line at 1. Yeah. So not this one, though. This is at x equals -2, so that one would be out. This is at x equals 1 as well, and this one would be out, right? This is at x equals -2 again as well. So we're building, right? I want you to start to feel comfortable. We're building. So that's kind of what I want you to really see first. So say it out loud, say it in your mind, but we can't divide by 0. So the first thing that you should look at is what can't you what x value would force you to divide by 0, so to speak. Okay? So if you look here, there's only one that's unique, and that's D. You see how it's x plus 1? It's the only one that's unique. We have two x plus 2s, and we have three x minus 1s. So what can't x equal? It can't equal negative 1 because negative 1 plus 1 is 0. And this graph right here has an asymptote at negative 1. So A goes with D. Just by default, we can see that. Okay. Now, let's work together here. Let's analyze what what's going on with this asymptote. Can we start to form a connection? Okay. Well, this asymptote is at 1. Okay. Now, this one had an effect on this. Okay. So I couldn't have a negative 1 there. So where is this coming from? Where is this horizontal asymptote coming from? Well, when looking at this, it might not be 100% obvious. Um, let's start to build on that. Okay, so we're working kind of slow. Maybe I should speed things up. It's 6:30, or not 6:30. We're 6 minutes and 30 seconds in here. It's actually 6:30 for me as well. 6:34. Kind of a weird coincidence. Anyway, so A goes with D, and let me spoil some other things here. Um, B goes with lowercase a. Okay, B goes with lowercase a there. Or wait, did I flip flop those? Apologies. No, sorry. That is lowercase b. Sorry. Maybe you have an idea of how I arrived at that. So we know that this asymptote is correct, right? But if you notice, this is the only one with a negative. Look at how the original function appears. We have one loop in the bottom and one loop in the top right. If you look at this graph, they seem to be flip-flopped. That's because it's been flipped. And the negative forces to flip. We know that. We know that's a thing. We know that when there's a negative, it forces things to flip. Okay? Building on knowledge that we already have. All right? So there's that. So check, check. We already used both of those. So we're learning more things, right? We're exploring. What else can we see here? Well, this has just a number in the numerator, and this has x plus 1 in the numerator, okay? So of the x equals 1 options here and here, could you maybe take a guess as which one's going to be which? So the one with so there's option A without anything in the numerator essentially, and option C that has something in the numerator. The numerator has to do with this horizontal asymptote. You can see here the horizontal asymptote is at 0, this one is at 1. So guess what? This one is A and this one is C. Maybe you're getting a sense of what's happening. Maybe. So lowercase a goes with, sorry, lowercase a goes with capital C, and then this is capital E. So CBE right there. Okay. Sorry if I'm flipping back and forth. I know it sucks that they're on two different pages. I apologize. I don't know who in the formatting world said, yeah, let's put these graphs on a different page than the functions. That makes sense. So CBE there. All right. So maybe, like I said, maybe we can start to realize something. Look at this asymptote. It's at 1, right? It's at y equals 1. All right. And look at this asymptote. It's also at y equals 1. But if we compare function d to function c, let's look at them. What do they have in common? Function d with function c. You'll notice that as far as the numerator is concerned, they both have an x. But this one is at -2 and this one says +1. but yet they both have a horizontal asymptote at 1. Curious. Curious. Why are they both at 1 if this number is different? Let's continue, all right? So we have 2 left. This one without a negative, this one with a negative. Easy peasy. Easy peasy. We know one's got to be flipped and the other's not. Which one is flipped? This one is flipped. This one is not flipped, right? So what does that mean? Sorry, they're on different pages. The E1 is positive, the F1 is negative. So F goes with F and E with D. F goes with F and E with D. Okay. And again, that's because the negative is causing us to flip. All right, we still didn't figure out the horizontal asymptote, but I hope you're getting a better sense of what's happening. The denominator has an effect on the vertical asymptote. The negative has an effect on us flipping, but maybe, just maybe, you haven't quite figured out the horizontal asymptote. Well, I'm going to go ahead and tell you now in the moment. And let's list some of these out. What are the characteristics of the graph of a rational function? Okay. It is has a vertical and horizontal asymptote. You could say split into two, kind of, right? It's kind of split into two pieces. Vertical asymptote is where denominator equals 0. So has a vertical and horizontal asymptote, and that vertical asymptote is when the denominator equals 0. So where is the horizontal asymptote? Horizontal asymptote is when, or is the quotient of the coefficients of the variables. Big words. Big words. And I just want you to write that down for now, and we'll see it in action here in a few moments. So let's get that written down, and we'll see it in action in a few moments. Horizontal asymptote is the quotient of the coefficients, or maybe I should say on the variables. I don't know. I'll stick with of. Is the quotient of the coefficients of the variables. Two ofs there. Sorry. So determine the intercepts, asymptotes, domain, and range of the rational function. So what do we know? The vertical asymptote is at x equals b. We know that the domain just simply can't equal b. That was what we already decided. Is because if you plug in b, if you plug in the number that makes it 0, you're breaking math, right? You can't divide by 0. So whatever this magical number is, if it's 2, 3, 4, whatever makes it equal 0. Our range, well, in this situation, what are the coefficients on our variables? 1 and 1. What is 1 divided by 1? It equals 1, right? So our horizontal asymptote is at y equals 1. And that means our range can't equal 1 because there is an asymptote at 1. Asymptotes are where your function can't be. So if you're looking at these graphs, why was the asymptote at 1 for this function and for this function, despite the -2 being different? Well, it's because they both had 1 over 1. It's because they both had 1 over 1. That's why. All right. All right. So, here once again is a breakdown of the hyperbola. We have the vertical, we have the horizontal, we have these two pieces, right? Like, I think hopefully you're getting a little more comfortable with the shape. We saw it 6 times, and I hope you're at least really comfortable with this asymptote. This asymptote, the coefficients is a little weird. I would agree, right? It's like, where'd you pull that out of? Like you just have that. Yeah, I just have it memorized, right? There is a reason why. There is a reason why. Um, but maybe another time. I want to just make sure we get the facts. Okay. So here is a more like general form, right? Our lovely A, H, and K. Okay. And please don't make me write it again. I'm just going to say it. Stretch, shrink, flip, horizontal shift, vertical shift. Okay. Now, this K thing is new, right? None of these had a K. I realize that. I own up to that. None of those had a K. Okay. This one does. So anytime you're in this form, this is the obvious vertical shift. So we love this form because it makes that horizontal asymptote more obvious. It's just the vertical shift, right? It's just the vertical shift. My arms, my hands coming together are the horizontal line. It's moving up and down. But if it's not written in this form, which clearly none of these were, well then it gets a little dicier when trying to determine the horizontal asymptote, and that's where my little rule comes into play of the quotients. Okay. All right. So let us look at some graphs. Okay. And let's try to do our best without using Desmos. Okay. So, what do we immediately know? There has been no horizontal shift. Okay. So, no horizontal shift. And this 0.25 in the numerator makes it a shrink. Okay. That's the only thing that happened. It makes it a shrink. Whereas this over here, because it's a 2, and 2 is greater than 1, 0.25 is less than 1, it causes a what's the opposite of shrink? Stretch. What? Jeez, oh Pete. A stretch. And the negative causes us to flip. Okay, I kind of ignore the negative when it comes to the stretch or shrink. The negative only causes the flip. Yeah. So when looking at this graph, we know that every single hyperbola looks like this, right? And if it didn't move up or down because there's no h and there's no k, all there is a shrink. So to demonstrate a shrink, I'm simply going to kind of make it closer to the center, right? Something like this, closer to the center. And compare that to the one with the stretch. Compare that to the one with the stretch. And the flip, I'm going to put it further away from the center. And again, we love Desmos, and it's not that big a deal if we draw it extremely accurate. But I do want you to have a general sense. We're kind of close. This distance is significantly larger when we start stretching. Okay, that's kind of the idea. Um, and we flipped. Okay. So if there's if no horizontal shift, no horizontal shift or vertical shift, so our asymptotes are both at 0 because we didn't move them left or right. Same with this one. Okay, we're not moving left and right. The asymptotes aren't moving. Okay. And again, please do not stress about your accuracy of your graphs. What I really want you to be on par with is like being able to read this and go, oh, it shrank and it didn't move left or right. Oh, it flipped and it stretched, but it didn't move left or right. And knowing that I didn't move left and right, whether you can graph them or not, I need you to know like where the asymptotes are, right? Just have an idea that, oh, they didn't move. They're both at zero. All right, let's have some movement, shall we? Let's have some movement. So what all is happening here? Well, there's no stretch or shrink. No stretch, no shrink. All right. But we did move right 3 and we did move up 5. So when it comes to our lovely hyperbola, what exactly is moving right 3 and up 5? Our asymptotes. We moved 1, 2, 3 units to the right, and we moved 1, 2, 3, 4, 5 units up. There are our lovely asymptotes. Okay? So when you draw the hyperbola, it is way up here, like so. Okay? Always going to make that plus sign of the hyperbolas because always going to have that intersection of the vertical and horizontal asymptotes. The shifting is what is moving the asymptotes, and not out of feel, identical to the logarithms and the exponentials. When we graphed an exponential function like e to the x minus 3, that, and then plus 3, or well, let's not do the same number, plus 4, well, an exponential has a horizontal asymptote. So the horizontal asymptote got moved up 1, 2, 3, 4. There is no horizontal or vertical asymptote. So this right 3, it just moved us over here somewhere, but it still continued forever. But the fact is that the bottom is now at 4 because of the vertical shift. Well, guess what? This vertical shift of 5 is now this horizontal asymptote. Same idea. Same idea. Oh, did not mean to flick it down like. All right. Whoops. I just accidentally deleted the horizontal axis of my graph. Okay. Let's do it again. What do we have here? We have a flip. We have a stretch. We have no horizontal shift, but we do have a down 4 situation. So let's get to work. Here is the axes, and we're only going down 4. So our vertical asymptote did not move. Here, let me do something. The horizontal asymptote is not moving left or right. It's not moving left or right. It's staying put at 0. Okay? Staying put at 0. But our horizontal asymptote, sorry if I misspoke. I flip back and forth between the two. But our horizontal asymptote, or horizontal asymptote is being shifted down 1, 2, 3, 4. Okay? And then we have a flip and stretch. So a flip means that we're not here and here. We are instead here and here. And then again, my stretch is the least of my worries, okay? I could care less how accurate your stretch is, to be honest. I just want you to know it's there. All right, I think we're doing good on time. Um, let's continue. And now we're finally hitting these last two problems where we don't exactly fit the norm, okay? We don't exactly fit the norm of what we would expect. So the problem says to rewrite the function in this form. And we could, but I gave you that fact about the quotient of the coefficients um, leading to the horizontal asymptote. So I don't think rewriting is 100% necessary. Okay, so I don't think we should do that task. I think we should just remember that the vertical asymptote is where or when the denominator equals 0, and the horizontal asymptote is the coefficient of the, or it's the quotient, sorry, misspoke. It's the quotient of the coefficients, right? It is the quotient of the coefficients. Okay? Let me rewrite coefficient. That's really sloppy. Coefficient, two F's, I think. If not, sorry. So when looking at this, I might sneeze. Excuse me. I could cut that out, but I don't want to have to go in and edit that. So it's staying in. All right. So we have what's going on in the denominator. Well, x can't equal 5, so thus, why can't it equal 5? Remind yourself, why can't it equal 5? Can you answer that question? It's been a minute since I said it. Because the denominator would be 0, and I can't divide by 0. Okay? That's why. Like, yeah, like you can memorize it, but like truly, why? Because you can't split something 0 ways. That doesn't make any sense. How can I split something into nothing? Right? So you can't divide by 0. Thus, if I can't have 5, thus there's an asymptote at x equals 5. That's your vertical asymptote. So if I have my axes here, I have my axes here. 1, 2, 3, 4, 5 to the right. X equals 5 is my vertical asymptote. And now, what are my coefficients? The coefficients are 1 and 1. What is 1 divided by 1? The quotient, division. Quotient is a fancy word for division. The quotient, 1 divided by 1, is 1. So that means there's a horizontal asymptote at 1. Okay. And there's no reflection. So with that being said, we know it looks like this. That was terrible. Now, I think this is a good moment while you draw that. I'm going to tinker real quick and pull this up on Desmos and then move it around a little bit more. Okay? Knowing some of this knowledge. All right. So, boom. Here we are. So take a look at what I've done. I want you to understand what I've got here. So if I get rid of this a, okay, if I get rid of this a, here's the original function, okay? Um, you can see here that over here to the right, it's approaching this gray horizontal line, correct? That is at 1. That is 1. 1, 2, 3, 4, 5. That is at 1. It's approaching y equals 1. And I could plot that if I'd like, okay? See that? So I'm going to put an a in front of x, okay? You see this a? So now I can make a whatever I want it to be. I could make it 2x plus 2. I could make it 3x plus 2. I could make it 4x plus 2. I could make it 5x plus 2. I am altering the coefficient out in front. I'm not altering the bottom. I'm leaving it as 1. So we can do some really simple math together. What's 4 divided by 1? 4. What's 5 divided by 1? 5. What's 6 divided by 1? 6. So that's the quotient. And look at where it's approaching. It's approaching whatever a is because we're doing a divided by 1. We're doing a divided by 1. So that's the quotient of the coefficients. A divided by 1 will give you an answer at a. So the asymptote is moving as that coefficient changes. Crazy, right? I mean, honestly, like I'm not being sarcastic here. That's crazy. So what happens if I put a coefficient on the bottom then? What if I make it 2? What if I make it 2? Well, now the asymptote should be at 7, because that's what a is, divided by 2, which is 3.5. So now the asymptote should be at half of whatever a is because we're dividing by 2 each time. So this asymptote is at 2 because the top coefficient is 4, the bottom coefficient is 2. What's 4 divided by 2? 2, right? You see that? It's the quotient of the coefficients. So if I make this b, not to get too crazy on you, right? But here's 4 over 3. What's 4 divided by 3? Like 1 and 1/3, right? So look, as I look at how I've defined the asymptote. The asymptote is defined as a divided by b, the quotient of a and b. Why am I doing a divided by b? Because a is the top coefficient, b is the bottom coefficient. And watch as the asymptote moves, as I change the coefficients, it stays in that perfect spot. It's truly incredible. It truly is incredible, right? How like that is how it works. It's crazy. What can I say except it's crazy? So enough of that. So what does that mean about the coefficients here? 2x plus 8, 3x minus 12. We know our horizontal asymptote is at 2/3. It's not at 1, it's not at 2, it's not at 3, it's at 2/3. 2 divided by 3. Now, the vertical asymptote is whatever makes the denominator 0. What number right there would make the denominator 0? 3 times what? Minus 12 would equal 0, right? Well, that's what we're asking. 3x, when is this equal to 0? Now, some of you might just be doing that in your head. You already know what the answer is. Spoiler alert, the answer is 4, right? But if you solve this little equation, you'll get the answer 4. Okay? So this number is not the dead giveaway of the horizontal shift, or, sorry, vertical shift, because I didn't move right to 12. It moved right 4 due to this 3 out in front. Okay? So x equals 4. One, two, three, 4 to the right, and 2/3. So somewhere in between, like right here, just below 1. And here, let me plot that one, Desmos, just to kind of confirm, because it is a little spicier, as I like to say, a little more difficult, but we got it, we got it. Um, if I plot, here, let me pull it up. Sorry. Well, so y equals 2/3. Are we right? Look at that. Getting closer and closer and closer, right? It's not getting close to 1. It's past 1. And you might be saying it's going to get close to this line right below it, right? But it's about to cross right over. Oh, see, it crossed. You see? It looked like it was getting really close to that line directly above it. But then it decided to break through. It's taking a while to get there, but it's getting there. I don't even know how far I need to go, but it keeps getting closer and closer and closer. It's eventually, I don't know why it's taking so long. I'm not going to lie to you. It's kind of interesting how long it's taking, but it's going to get there. You might think, oh, it looks like it's about to stop at that line. It's about to break through, I promise you. Come on, where's the breakthrough? Oh, it broke through right there. You see? I just had to zoom in. It broke through. It's taken a while, but it's getting closer. Anyways, who cares? The point is it's getting motherfucking close. That's for darn sure. You zoom out, it looks like it's already on top of each other. So anyway. All right, back to the too much fun. All right. 35 minutes. Ooh, me in that sweet spot. And look at that. We're done. So, um, plot this, plot this. So, with that being said, let's have a quick recap before I let you go. Well, number one, we're not going to ignore my request right now. We're gonna do the big ideas. We're all gonna open it up. We're gonna do the big ideas, and we're gonna knock the first assignment out. Okay. Um, there, just please do that. Okay. Please, please do that. Please use this time to complete the big ideas this time. But in conclusion, our vertical asymptotes when the denominator is zero. Our vertical asymptotes, the coefficients. That is when it's the tricky version, right? When it's in this nice version, we like the nice version, which is why the problem said to rewrite, but there's no need to rewrite, okay? We like this version, we like the other version too. But when it's in this version, it's clear as day what the vertical shift is. It's clear as day what the horizontal shift is, and it's clear as day whether you're stretching, flipping, and shrinking, right? So when it comes to these graphs, that's what we're looking for. What are other types of questions you could be asked? Domain and range, right? But the domain and range play off of the asymptotes. We already experienced this with exponential and logarithmic functions, people. We already experienced this, okay? When looking at this graph, this asymptote is restricting our range. I cannot ever equal the purple line. My range, simply put, it cannot equal 5. That is my range. Everything else, free game. Simply put, I cannot equal 5. Okay? And then my domain, simply put, I cannot equal 3, for example, on this problem. Okay? This asymptote is a clear representation of what flies and what does not fly. Okay? Everything else is free game. Look at this. This function's infinite. It's just those couple of moments. I don't know what's dinging over there. It's just those couple of moments where we're restricted because of the asymptotes. Okay? And with that, we're at a sweet spot, just under 38 minutes. I appreciate your time. I appreciate your watching. This video will be posted on Canvas so you can watch it on your own time. I appreciate you making it to the end and paying attention and taking notes. I will see you next class period. Have a splendid day. See you later.